Hello students. So we were doing complex numbers and we have defined what is a complex number. Okay. Let's see the geometrical representation of complex number. So the number z is equal to x plus iy can be represented in a plane called complex plane where this x is real axis and y is a imaginary axis. Okay. So any number if it is taken 1 plus 2i, then you have to put x equal to 1 and y equal to 2. Okay, so this is the point 1 comma 2. Okay, same way for the negative numbers. Next is algebra of complex numbers. So first one is addition. For any complex number z1, z2, okay, you can write addition as, so this is x1 plus iy1 plus x2 plus iy2. You have to take real parts together and imaginary parts together. Okay. Same way you can define for subtraction. Okay. Then there is a negative of a complex number. So negative of a complex number is given by, second is subtraction. Then negative of a complex number is given by minus z. So you have to write this as x plus iy. It is minus x minus iy. Okay. Minus z is also a additive inverse of a complex number. Okay. Next we have properties of complex numbers. So sum, subtraction, then multiplication, division, you will always get a complex number. If you add two complex numbers or subtract two complex numbers, you will get a complex number. So commutative property for addition and multiplication, z1 plus z2 is same as z2 plus z1. Okay. Same way z1 z2 is equal to z2 into z1. Then associative property is also true for addition and multiplication. Additive identity is 0 plus 0i. Okay. If you add z by 0 plus 0i, you will get the same number, right? Additive inverse is minus z. Then multiplicative identity is 1. That is 1 plus 0i. So if you multiply z by 1 plus 0i, you will get z. Okay. Multiplicative inverse will find. Inverse. So for multiplicative inverse, z inverse is 1 upon z. Okay. So 1 upon x plus iy. So you have to rationalize this. X minus iy into x minus iy. This is a plus b, a minus b, x square minus I square y square. I square is minus 1. So this becomes x square plus y square. Okay. So this is the multiplicative inverse. Then we have a distributive property and cancellation law. Okay, next important thing is conjugate. Conjugate of a complex number. Okay. For a complex number z equal to x plus iy. Its conjugate is denoted by z bar, okay, and it is given by x minus iy. So you have to put minus sign for the imaginary part. Okay. Now for example, if you have z equal to 2 plus 3i, okay, then its conjugate will be 2 minus 3i. Now what if it already has a negative sign? Suppose you have minus 2 minus 3i. Then conjugate, real part remains same. This is minus of minus, so it becomes plus. Okay. Here are some identities given in the textbook. Okay. z1 plus z2 the whole square. This is same as that is for real numbers. Okay. So while proving that, you have to use some laws. Okay. Same it is for z1 minus z2 the whole square and z1 plus z2 the whole cube. Okay. Cube is also same. This is a square minus b square. Okay. Yes, same. Then we have for conjugate there are some properties, and after conjugate we have sum and product of a conjugate is a real number. Okay, that is if you add a complex number with its conjugate. Okay, so this will be x plus iy plus x minus iy, right? So it will be a real number. Same way if you multiply conjugate, so x plus iy into x minus iy. So using a plus b, a minus b, you will get x square plus y square. Again, it is a real number. Okay. Then we have a modulus. Modulus of a complex number. We call it mod. So modulus is given by mod of z, which is root of a square plus b square, or we have taken x plus iy. So x square plus y square. Okay, this is modulus. And some properties are there in the textbook. First, we'll take one example for this. If you have a complex number, say 3 plus 5i, then modulus is given by root of 3 square plus 5 square. Okay. So some important properties you note down. Inverse of a complex number is conjugate upon mod square. Okay. Then conjugate when it is multiplied, you will get a modulus square. Okay. Then we have z1 z2 is equal to z1 z2. This is related to modulus. Then its division is also given by this. Then multiplication whole conjugate. And addition or subtraction. Then division, okay. Let's solve some examples which are given in the textbook. You have to find multiplicative inverse of 2 minus 3i. Okay, one way is by doing that 1 upon thing. Okay, and second way is I've given one formula, that is inverse is given by conjugate upon mod square. Okay. So this is defined 2 minus 3i. So its conjugate is 2 plus 3i, correct? And modulus is 2 square 4, and this is 9 root 30. So inverse is 2 plus 3i upon root 30. Okay, which can be written as 2 upon root 13 plus 3 upon root 13i. Okay, this is by using the property. Next question which is given is you have to express the following in the form a plus ib. Okay, so first one is given 5 plus root 2i upon 1 minus root 2i. So here you have to rationalize this. Okay, the denominator we want a real number, so you have to multiply by its conjugate. So multiplying this also will get 5 plus 5 root 2i plus root 2i, simple multiplication. Okay, root 2 into root 2, 2i square. It will be 1 square minus root 2 square I square. So 5 I square is minus 1. So minus 2. 5 minus 2 is 3. Adding this 2, you will get 6 root 2i. 1 minus 2 I square is again minus 1. Minus minus plus 1 plus 2, 3. So we will get 3 upon 3 is 1 and 6 upon 3 is 2. Okay, this is of the form a plus ib. Then some more given. I into I square, I cube, 8 cube 64 into 8, or I can write this as 8 into 64. Okay, and minus I cube is minus I, right? So you can cut this. 4 I square is minus 1, minus 1 into minus 1 plus 1, and this is also plus 4. 64 4 ja 256. Okay, then 5 minus 3i the whole cube. For this you have to use the formula a plus b the whole cube. A cube 5 cube is 125 minus 3 5 square into 3i plus 3 into 5 into 3i square 9i square plus 9i 3 cube 27. This is minus I cube. Okay. 25 into 9. 225 I. 45 into 3. 135. I square. So minus 135. And 27 I cube. I cube is minus I. Minus into minus plus. 125, 135 minus 10. 225 minus 27. 198. I. Okay. So this is in the form x plus iy. Okay. Second one, you have minus root 3 plus minus root 2 into 2 root 3 minus r. Okay, or to multiply. So this with this and this. Root 3 into 2 root 3 is 2 into 3. Then root 3 into I plus root 3i. Root of minus 2 into 2 root 3. Minus 6 and root of minus 1 is I. Okay. Then minus root 2 into minus I. Minus root 2 is root 2i. So root 2 I into I squared. This is 6. This remains same. And this is I square is minus 1 minus minus plus. Okay. So I this is with I. So I is with this and your real part is this minus 6 plus root 2. And this is root 3 plus 2 root 6 I. Okay.